Before we ask whether we are alone in the universe, there is a quieter question we almost never ask. How close would anyone need to be for us to even notice? We tend to imagine the galaxy as a shared space, a place where civilizations, if they exist, should eventually cross paths. But what if that expectation comes from Earth, not from physics? What if the universe isn't silent because no one is out there, but because distance makes presence indistinguishable from absence? Some estimates suggest that the nearest technological civilization could be tens of thousands of light years away. Not hidden, not extinct, just far beyond intuition. And if that's true, then the silence we hear is not a mystery. It is the natural sound of scale. Part 1. Distance is not emptiness. For decades, humanity has looked into the night sky with a quiet expectation. Not certainty, not proof, just a feeling that if intelligence exists elsewhere in the galaxy, it should be close enough to matter. For most people, the idea of extraterrestrial life is inseparable from the idea of neighbors, nearby stars, nearby worlds. Civilizations separated by space, but still sharing the same cosmic present. And when we hear nothing, the silence feels wrong. So the first question becomes emotional before it becomes scientific. Why does it feel like no one is nearby? But what if that feeling comes from a mistaken intuition? What if we've been asking the wrong question all along? Not, are we alone, but how close would anyone even need to be for us to notice? This distinction matters more than it seems, because silence does not automatically mean absence. Sometimes it means separation. What if the universe isn't quiet because life is rare, but because it is far away? Some models suggest that the nearest technologically capable civilization may lie tens of thousands of light years from Earth, possibly as far as 33,000 light years. Not avoiding us, not watching us, simply distant. And if that is true, then the silence we experience is not mysterious at all. It is expected. Tonight, we're going to explore what that distance really means, not as an abstract number, but as a physical and temporal boundary that reshapes everything we assume about intelligence, communication, and cosmic companionship. We'll see why a galaxy filled with intelligent life can still feel empty, why advanced civilizations may never know one another exist, and why the universe can allow awareness to emerge without ever allowing connection. But to understand that, we first need to confront something deeply uncomfortable. Our intuition about distance is wrong. Part 2. When scale takes over. On Earth, distance feels negotiable. A few hours of travel connect cities. A day connects continents. Even the farthest places on our planet feel reachable with enough planning and technology. That intuition follows us into space. When we imagine intelligent life among the stars, we carry the same assumption with us. If they exist, they should be reachable. If they are advanced, they should be close enough to matter. But the galaxy does not agree. The Milky Way is not a larger version of a familiar world. It is a structure so vast that scale itself becomes the dominant force. Our galaxy stretches roughly 100,000 light years from edge to edge. It contains hundreds of billions of stars, arranged in a rotating disk, a dense central bulge, and a faint outer halo. These stars are not evenly distributed. Some regions are crowded and violent. Others are sparse and quiet. From our position, about 26,000 light years from the galactic center, we do not see the Milky Way as a whole. We see only a narrow slice of it. Much of the galaxy is permanently hidden from us, not because of secrecy, but because of distance and time. Light from distant regions began its journey long before human history, before agriculture, before writing, before cities. When that light finally reaches Earth, it carries information from a past that no longer exists. This leads to a realization that quietly changes everything. At galactic scales, distance cannot be separated from time. A star system 33,000 light-years away is not simply far. It is separated from us by 33,000 years of history. If an intelligent civilization exists there today, we cannot observe it as it is now. We can only observe what it was doing tens of thousands of years ago. And that changes what nearby really means. In a relativistic universe, proximity is not measured by kilometers or even by light years alone. It is measured by whether two civilizations can ever share a meaningful present. By that definition, most of the Milky Way is not nearby at all. Even within the same galaxy, civilizations can be so separated by distance that they are effectively isolated forever. They may orbit the same galactic center. They may follow the same physical laws, yet never exist in the same moment. This is where many expectations collapse. We often imagine the Milky Way as a shared environment, a common stage where civilizations might encounter one another. But in reality, it behaves more like an archive, a layered record of different moments in time. Each region preserves its own history. Observation does not reveal a shared present. It reveals different pages from different eras. So when we talk about a civilization 33,000 light-years away, we are not talking about a neighbor waiting to be found. We are talking about a historical event. And that realization changes the silence. It no longer feels strange. It feels structural. Part 3. Why the galaxy is not crowded. The idea that intelligent civilizations should be close to one another comes from a deeply human assumption. If something is possible, we imagine it happening often. And if it happens often, we expect to see it nearby. But the galaxy does not organize itself around human intuition. The Milky Way is not a uniform field of stars. It is an uneven structure shaped by chance, violence, and time. Stars form in different regions, under different conditions, at different moments, and those differences matter. Near the galactic center, space is dense and energetic. Stars are packed closely together. Supernovae are more frequent. Radiation levels are higher. Gravitational interactions are stronger and more disruptive. In such regions, planetary systems struggle to remain stable for billions of years. At the outer edges of the galaxy, conditions are calmer, but these regions are poorer. They contain fewer heavy elements, the materials required to form rocky planets, complex chemistry, and eventually life. Between these extremes lies a broad, imperfect zone, often described as the galactic habitable zone. Not a safe ring, not a guarantee, just a region where probability improves slightly. Even there, suitable planets are not assured. Each requirement narrows the field. Stable orbits, long-lived stars, liquid water, protective magnetic fields. Life itself narrows it further. On Earth, life appeared early, but complex multicellular life took billions of years. Intelligence arrived only at the very end. This was not inevitable. It was a fragile chain of contingencies. Break one link, and the outcome changes. Here is the key point that undermines the idea of a crowded galaxy. Even if life is common, intelligence is not evenly distributed. It arises when countless evolutionary accidents align, in the right order, over the right amount of time. And time is not evenly available across the Milky Way. This produces a galaxy where intelligence appears in isolated pockets, not in dense clusters. From this perspective, a separation of 33,000 light-years is not extreme, it is ordinary. Part 4. Evolution is not synchronized. There's another assumption quietly shaping how we imagine intelligent life in the galaxy. Not just that it exists, but that it exists at the same time as we do. This assumption feels natural. We are here now, so if others exist, we picture them sharing this moment. But evolution does not coordinate itself across space. On Earth, life appeared early, but complexity did not. For billions of years, our planet was inhabited only by simple organisms. Multicellular life emerged late. Intelligence emerged later still. Technological civilization occupies a razor-thin slice of Earth's history. There is no reason to believe other worlds follow the same schedule. Some planets develop life quickly and then stall. Others remain microbial for eons before a sudden transition. Some reach intelligence early and vanish long before Earth forms. Others may not reach it until long after humanity is gone. This creates a galaxy filled not with contemporaries, but with different evolutionary moments. Two civilizations can share the same galaxy and never coexist. They may orbit the same galactic center. They may follow the same physical laws, but their windows of technological existence may never overlap. Even if intelligent life is common in space, it may be rare in time. Technological intelligence narrows the window further. A species must not only evolve intelligence, it must develop tools, language, and cumulative knowledge. It must build complex social systems and maintain them under pressure. And it must survive long enough to enter a phase where its technology becomes detectable beyond its own planet. That detectable phase may be brief. Civilizations change, technologies evolve, communication methods shift. A society may grow quieter rather than louder over time. From the outside, such a civilization would appear to vanish, even if it continues to exist. This introduces a powerful temporal filter. The galaxy may host many intelligent societies across billions of years, but very few of them are likely to overlap with us right now, and fewer still would overlap nearby. Distance intensifies this effect. A civilization 33,000 light-years away is also separated from us by 33,000 years in time. If we detect a signal from such a civilization, we are not detecting its present, we are detecting its past. By the time that signal arrives, the civilization that produced it may have transformed beyond recognition or disappeared entirely. Replies face the same delay. Meaningful exchange collapses before it begins. Part 5. Light is a limit, not a bridge. Light feels like connection. It carries images across space. It brings us information from distant stars. It allows us to see galaxies billions of light-years away. Because of this, it is tempting to think of light as a bridge between civilizations. But in a relativistic universe, light is not a bridge. It is a limit. Nothing that carries information can move faster than light. This is not a technological problem. It is a structural feature of reality. Once distances reach tens of thousands of light-years, this limit stops being abstract. It becomes absolute. A signal sent across 33,000 light-years does not simply weaken. It arrives 33,000 years late. By the time it reaches its destination, everything that gave it context may be gone. Languages change, cultures transform, civilizations collapse or evolve into something unrecognizable. Any reply would require another 33,000 years to return. This is where communication quietly fails. Conversation assumes feedback, continuity, shared context. Across galactic distances, none of these conditions survive. Instead, contact becomes one-sided. A civilization may detect a signal from another world without knowing whether the sender still exists. The message becomes a historical artifact, not an invitation. Contact turns into discovery, and discoveries do not speak back. The universe allows awareness, but it does not guarantee connection. Part 6. Why signals fade before they arrive. For much of the 20th century, the search for extraterrestrial intelligence was guided by a hopeful idea: that advanced civilizations would reveal themselves accidentally. Radio broadcasts, television signals, radar emissions, all of them leaking into space. Researchers once imagined the galaxy slowly filling with overlapping bubbles of radio noise, each one betraying the presence of technology. But this idea depends on a misunderstanding of how signals behave over large distances. Radio waves spread outward. Their energy dilutes as distance increases. By the time an unintentional signal has traveled a few thousand light years, it becomes indistinguishable from background noise. At 33,000 light years, it is effectively gone. This means accidental detection is almost impossible at galactic scale. Only two kinds of signals remain detectable across such distances: extremely powerful transmissions and deliberately focused ones. Both require intent. A civilization must choose to announce itself, choose where to aim, choose how long to transmit, and that decision must persist across generations. Technology, however, does not naturally grow louder. It grows quieter. As communication systems become more efficient, they require less power and leak less energy. Signals become narrower. Noise is reduced. On Earth, our strongest radio leakage peaked decades ago. Since then, we have become progressively harder to detect. If other civilizations follow similar paths, their detectable phase may be brief, a narrow window measured in centuries, not millennia. From the outside, such civilizations would appear to flicker briefly into visibility and then fade back into silence. Distance compounds this effect. Interstellar space is not empty. Plasma, radiation, and stellar activity distort and mask weak signals. Against that backdrop, artificial transmissions must be extraordinarily precise to stand out. The conclusion is quiet, but unavoidable. The absence of detected signals does not imply the absence of intelligence. It implies that detection is difficult by design. Distance weakens signals. Time misaligns civilizations. Technology evolves toward invisibility. Together, they make silence the default. And this raises another expectation we rarely question. Part 7. Why the galaxy is not filled with visitors. If intelligent civilizations exist, a natural question follows. Why don't we see them? Why isn't the galaxy filled with probes, artifacts, or visitors? For decades, this question shaped expectations. The assumption was simple. If even one civilization mastered interstellar travel, it would eventually spread across the Milky Way, leaving evidence everywhere. But this assumption carries Earth-based intuition into a cosmic setting, and the universe does not cooperate. Interstellar travel is not just difficult, it is slow. Even at a significant fraction of the speed of light, crossing the galaxy would take tens of thousands of years. Journeys would outlast cultures, languages, and political systems. Any expansion effort would fragment over time. Colonies would become isolated, separated not only by space, but by centuries of delay. Coordination would collapse. Continuity would erode. Expansion would not resemble a wave, it would resemble a fragile chain of disconnected outposts, each one drifting away from its origin. There is also the question of motivation. Intelligence does not evolve to conquer space, it evolves to survive locally. Curiosity alone does not guarantee expansion. A civilization may find that the cost of spreading outward far exceeds the benefits. Resources may be abundant at home. Energy may be better spent on efficiency rather than reach. Some societies may turn inward. Others may prioritize stability, sustainability, or virtual existence. Interstellar colonization may be rare not because it is impossible, but because it is unnecessary. Even if expansion occurs, it may leave little trace. Advanced technology tends toward optimization, not excess. Energy use may become subtle, infrastructure compact. Large, galaxy-spanning empires are not a requirement of intelligence. They are a narrative preference. From far away, an advanced civilization may look indistinguishable from an empty star system. No megastructures, no obvious signals, no visible footprints. Just planets, stars, and silence. Distance reinforces this invisibility. A civilization 30,000 light-years away could expand, thrive, and disappear without ever intersecting our region of the galaxy. Not because it failed, but because the galaxy is vast enough to keep stories separate. The absence of visitors does not require catastrophe. It requires scale. Part 8. Intelligence as a local phenomenon. One of the hardest ideas to accept is that intelligence may be fundamentally local. On Earth, intelligence feels central. We communicate globally. We share information instantly. We assume awareness spreads naturally. We project this intuition onto the universe. But the universe does not reward reach. It enforces limits. Intelligence emerges within specific environments. It adapts to local conditions. Its technologies reflect nearby resources, local physics, and immediate pressures. Beyond that zone, influence fades rapidly. If civilizations are separated by tens of thousands of light years, each one effectively inhabits its own universe. The broader galaxy exists only as an abstraction, understood through equations, models, and distant observations, not through experience. Contact is not part of daily reality. Isolation becomes normal. From this perspective, awareness does not imply connectivity. Understanding does not require neighbors. A civilization may reach profound insight into the nature of reality while remaining entirely alone in practice. This reframes the meaning of intelligence itself. Intelligence is not a network. It is a process, a local phenomenon briefly illuminated against a vast background of space and time. Multiple civilizations may exist simultaneously within the Milky Way, but simultaneity does not equal proximity. Shared time does not overcome distance. Even awareness of one another does not produce connection, only separation. Each civilization experiences the universe from a single point, bound by the same laws, limited by the same speed of light, but isolated by scale. From this angle, humanity's situation is not exceptional. We may not be early, we may not be late, we may be typical. A single instance of awareness emerging quietly on the edge of a spiral arm, looking outward, listening, and finding silence that makes sense. Part 9. The Fate of Dialogue in a Relativistic Universe. Dialogue assumes proximity. It assumes response. It assumes that questions can be answered before they lose meaning. Across interstellar distances, those assumptions collapse. At 33,000 light years, communication does not form a conversation. It forms an archive. A signal detected today describes a past that can never be revisited. We cannot ask why it was sent. We cannot clarify intent. We cannot know whether the sender still exists. Every transmission becomes a historical artifact, not a greeting, not a reply, just evidence that someone was there. Replies face the same barrier. Any response we send will arrive tens of thousands of years later, long after cultures change, long after motivations fade, long after survival itself is uncertain. Meaningful exchange requires continuity. The universe does not provide it. The speed of light does not merely delay messages, it fractures time. Each civilization experiences a different slice of history. What feels like now is never shared. Even deliberate attempts at contact become symbolic acts. A civilization that broadcasts must accept that it will never hear back. The message is not a request, it is a monument, cast into the future with no expectation of response. This changes the emotional tone of the search for extraterrestrial intelligence. We are not waiting for a conversation, we are searching for confirmation. Confirmation that intelligence has existed elsewhere, that awareness is not unique. Detection would not mean hello, it would mean discovery. And even that discovery would arrive incomplete, stripped of context, frozen in time. A civilization may learn that it was not alone without ever knowing who the others were. Dialogue in a relativistic universe is not forbidden, it is irrelevant. Part 10. Loneliness as a property of scale. It is tempting to interpret cosmic silence emotionally, to hear it as rejection, as failure, as loss. But at the scale of a galaxy, loneliness is not a feeling, it is geometry. When distances stretch across tens of thousands of light years, separation becomes inevitable. No matter how many civilizations exist, intelligence does not need to be rare for isolation to dominate experience. Even a galaxy filled with technological societies would still feel empty from any single point within it. The spaces between minds are simply too large. On Earth, loneliness is defined by absence within reach. In the cosmos, loneliness is defined by reach itself. The universe is not withholding contact, it is enforcing distance. Every civilization, no matter how advanced, is confined to a narrow island of influence, bounded by time, bounded by light. This reframes the human condition. We are not uniquely isolated. We are normally isolated. Any intelligence that arises in a relativistic universe inherits the same separation. Awareness blooms locally, surrounded by vast silence. Not because others are gone, but because they are elsewhere. Seen this way, the silence loses its menace. It becomes a neutral feature of reality, like gravity, like entropy. It does not judge, it does not threaten, it simply is. The universe is not a crowded room waiting to be entered. It is an archipelago of minds separated by oceans too wide for voices to carry. Thank you for walking this path through time and space with me. This story can feel frightening, or it can feel inspiring. It depends on how you look at it. So write in the comments, what do you feel when you look at the night sky? Do you feel the cold of loneliness, or the excitement that this entire vast galaxy is ours, and ours alone? I read every opinion. If this video made you think, hit the like button. It's the best way to support the channel. Subscribe and turn on notifications. We'll continue to look for light in the darkness. The cosmos may be empty, but as long as we are here, it is not meaningless. See ya.